Think about the mild annoyance you feel when you send a text message and have to wait 3 or 4 minutes for a reply. Now, imagine sending a critical instruction to a machine and waiting 24 full hours just to see if the message was delivered. That is the daily reality of communicating with Voyager 1. Built nearly half a century ago, this tiny machine is currently floating through the freezing vacuum of space, over 25 billion kilometers from Earth. And on November 18, 2026, it is projected to cross a distance threshold that humanity has never touched. It will hit a mark precisely 1 light day away. A radio signal traveling at the absolute speed limit of the universe, the speed of light, will require a full 24 hours to cross the empty space between our planet and the probe. We have never successfully maintained an operational tether stretched this thin across the dark. Yet engineers never planned for a 24-hour communication delay. This extreme reach is an accident, born from a project that was originally intended to stay relatively close to home. When Voyager 1 launched into the Florida sky on September 5, 1977, its itinerary was strictly mapped to the outer planets of our own solar system. During that initial phase, the communication delay was measured in mere minutes. It gave us our very first close-up views of Jupiter, capturing intricate details of its swirling storms and orbiting moons. The rapid stream of discoveries continued as the probe reached Saturn, revealing entirely new planetary rings to the scientific community. But after leaving Saturn, the probe didn't stop. As it pushed deeper into the void, the physical gap widened by more than 1 million kilometers every single day, steadily stretching the communication lag from minutes into hours. Eventually, it reached the heliosphere, an enormous protective bubble of energetic particles created by our Sun that encases all the planets. In 2012, Voyager 1 pierced that bubble, slipping through the outer edge to become the first human-made object to enter the interstellar medium. Leaving the Sun's protection turned the craft from a planetary sightseer into an interstellar endurance tester, fighting a daily, losing battle against the expanding void. Today, the physical toll of that environment is severe. Voyager is isolated in freezing darkness, and the radioactive isotopes that power its internal systems are steadily decaying. This is a machine running on mid-20th century technology, originally monitored by engineers in rooms that looked like this. To keep it alive today, NASA is performing a deliberate, slow-motion triage. They are methodically shutting down scientific instruments one by one, sacrificing the probe's eyes and ears to conserve the tiny amount of electricity keeping its core computer warm. Every step of this triage is agonizingly slow. If a technician sends a troubleshooting command to fix a glitch, they have to sit on their hands for a full day before the aging computer can process the instruction and reply. Yet inside today's digital mission control centers, teams are completely dedicated to maintaining this fragile link. The engineers are fighting to stave off the absolute inevitable, the moment when the power finally runs dry, and that 24-hour tether snaps forever. Soon, likely within the next decade, that total power failure will arrive. The remaining internal heaters will freeze, and the radio signal will drop into permanent silence. But Voyager's utility doesn't end when its instruments die. Its final payload is designed specifically for that silence. Bolted to the exterior of the spacecraft is a phonograph record made of gold-plated copper. This golden record is a time capsule. It carries the sounds of wind and waves, a curated selection of global music, and encoded images of life on Earth, sent blindly out into the cosmos. Once it goes quiet, Voyager will continue coasting on its current trajectory, heading toward a distant star system known as Gliese 445. The physical gap is staggering. Even traveling at over 60,000 kilometers per hour, the dead probe won't reach the vicinity of that star for roughly 40,000 years. Think about the sheer weight of that timeline. 40 millennia from now, human civilization may be entirely unrecognizable. We might be living among other stars, or we might no longer exist at all. Even if there is no one left to remember who built it, this small machine will keep drifting through the dark. It will endure as a permanent piece of our planet, an accidental monument proving to the universe that we were here and that we looked up and wondered what else was out there.